What if life in space didn't just exist, but was already evolving into something far more powerful than anything we've ever seen on Earth? Recently, aboard the Tiangong Space Station, Chinese scientists made a discovery that is quietly shaking up the global science community, and it hasn't even hit the mainstream news cycle in the way it should. Hidden behind routine scientific announcements and microbiology papers is a revelation straight out of science fiction. A new type of bacteria has been found, one that didn't just survive in space but adapted. The newly discovered bacterium is called Niallia tiangongensis, named after the Tiangong station where it was found. At first glance, it might seem like just another microbial study, but what's inside this microscopic organism has scientists stunned. It's showing traits no normal Earth-based bacterium should have, specifically extreme resistance to radiation, oxidative stress, and space-based environmental hazards that typically destroy life. Space is hostile. There's no breathable air, no gravity, and dangerous levels of cosmic radiation. It's an environment so harsh that unprotected human cells die almost instantly. And yet, this bacterium didn't just resist space conditions, it adapted to them. Now here's the first big question. How did it get there? Most scientists agree that Niallia tiangongensis likely originated on Earth and made its way to the station via cargo or human presence. In space research, this is called forward contamination, when Earth life accidentally hitches a ride on spacecraft. But here's where it gets mind-blowing. The bacteria inside Tiangong didn't remain Earth-like. Instead, it mutated, developing new biological defenses to survive its alien surroundings. It essentially became a new species, shaped by microgravity and radiation exposure. This isn't evolution across millions of years. This happened in real time, right above our heads. Some are calling this our first real-time glimpse of space-driven evolution, nature rewriting its own code in an artificial environment. That idea alone is worth a Netflix documentary. If Earth microbes can evolve in orbit into new, more resilient forms, what does that mean for the future of space travel, planetary protection, or even the search for alien life? One possibility is the idea of panspermia, the controversial theory that life in the universe can spread through space via asteroids, comets, or even spacecraft. If a simple Earth bacteria can evolve and survive in orbit, what's stopping life from doing the same across light years? Think about this. Could a single microbe, drifting for centuries through the void, survive the journey to another world and seed life? We've always asked if there's life out there, but this story flips the script. What if we're the ones spreading life, intentionally or not? Now, here's where things get weird. Online theorists and space watchers are already asking, what if this bacteria isn't entirely Earth-based anymore? What if, in the extreme conditions of space, it mutated into something that's no longer Earth's creation, but something new? Some even suggest it may have interacted with unknown particles or cosmic radiation sources we don't fully understand. Could space itself, with its unique energies and quantum-level forces, act as a sort of incubator for alien traits? Let's be clear, there is no official evidence that Niallia tiangongensis is alien, but the line between Earth-based and space-evolved life is suddenly very blurry. And when you consider how little we understand about microbial evolution in space, it opens the door to big, unsettling questions. But it's not all doom and mystery. This superbug might actually help us colonize space. Scientists are already studying how the bacteria's resistance mechanisms work. If we can understand or even replicate how it survives radiation and stress, we could apply that knowledge to create radiation-proof materials for astronauts, genetically modify food to grow in low-gravity environments, design probiotics that keep humans healthy on Mars or the Moon, and advance medical science on Earth in treating oxidative damage and aging. It's like discovering an alien blueprint inside something we brought with us. But here's the real threat. and why some scientists are quietly concerned. If Niallia tiangongensis or something like it is accidentally brought back to Earth, and if it behaves unpredictably, we could be dealing with a form of life that doesn't follow the normal rules. Earth's immune systems, animals, crops, nothing here has evolved defenses against microbes shaped by radiation and zero gravity. In other words, we're not immune. This is why strict protocols exist in every space agency for handling space-exposed biological material. Because even a harmless bacteria, if mutated enough, could trigger ecological chaos. Just look at what regular antibiotic-resistant bacteria are doing to hospitals today. Now, imagine that, but space-enhanced. So here we are. A single microbe, found on a floating laboratory orbiting Earth, might represent a turning point, not just for microbiology but for humanity's place in the cosmos. Because here's the truth. Space isn't just about stars, black holes, and silence. It's becoming a laboratory, a petri dish, a new breeding ground for life. We used to look up at the night sky and wonder, is anyone out there? Now we need to ask, what are we creating up there? And, more importantly, are we ready for it? So now I ask you, the viewer, do you think this bacteria is just a weird mutation from Earth, or is it something more? Drop your theories in the comments and tell me this. If we discover life that we accidentally created in space, does that make us the aliens? Don't forget to like, subscribe, and hit the bell, because space is no longer empty. It's alive. And this is just the beginning.